In an experiment, the number of bacteria in a culture, N, in thousands, is measured at time intervals, T, of 1 day. It is thought that N and T are related by a formula of the form N is equal to A T to the B, where A and B are constants to be found. Some values of N and T are given opposite. By drawing a suitable straight line graph, we want to show that the relationship is of this form, and we want to find the values of the constants A and B. Let's consider the formula N equals A T to the B. If we take logs of both sides, we get log N is a log A T to the B. And using our knowledge of logarithms, we can rewrite the right-hand side as log A plus log T to the power B, and then once again simplify further to log A plus B times the log of T. If the relationship is of this form, then y equals c plus mx, and we know y equals mx plus c is the equation of a straight line. We can see here that the intercept c would be log a, the gradient m would be b, and y is log n, and x is log t. When we plot a graph, we plot y against x, and here that means we're going to need to plot log n against log t. So we're going to need to work out values for log n and log t. So here we have some values. I've taken logs to the base 10, but you could take logs to any base. We need to plot the values of log n as the y-axis against log t on the x-axis. So we plot 0.3, 0.78, 0.48, 1.13. Of course, on graph paper you can do this more accurately. 0.6 against 1.38. 0.7, 1.57, and 0.78, 1.73. And this is a straight line, which confirms the relationship that n is equal to a times t to the b. We can see the intercept here is 0.2, and we also need to know the gradient of this line. We can see we go from 0.6 to 1.38, which gives this distance as 0.78. This is 0.4. The gradient of the line then is 0.78 divided by 0.4, which is 1.95. We know the intercept was 0.2 and the intercept is log a. So log a is 0.2. A then is going to be 10 to the power of 0.2, since we took our log to base 10. And this gives us 1.58, correct to 3 significant figures. We also know that b is the same as m, and we've worked out that the gradient was 1.95.